Hello grade 9 students, welcome to our virtual class for the 4th quarter, week 7. I'm Abigail Sarmiento, your science teacher. Our lesson for today is about heat engines. Work can be easily transformed into heat. It is very evident when doing work. All the work we do in overcoming friction is completely changed to heat. Example, eating, which is a method of work due to tearing and chewing food particles, can be completely converted into heat, which is the product of mechanical and chemical combustion and absorption of nutrients occurred in the digestive system. Reserving the process is impossible, such as changing heat completely into work. To make it possible, we have to convert some heat to mechanical energy. This would happen only using heat engines. Heat engines is a device that changes thermal energy into mechanical work. A device that changes thermal energy into mechanical work is a heat engine. A heat engine consists of a gas confined by a piston in a chamber. If the gas is heated, it expands, making the piston move. A practical engine is operated through cycles. The piston has to move back and forth. When the gas has heated, the piston moves up. When it is cold, the piston moves downward. A cycle of heating and cooling will move the piston up and down. A very important component of heat engines, then, is that two temperatures are involved. At one cycle, the system is heated. At another, it is cooled. Three things happen in a full cycle of a heat engine. First, heat is added. It is an input heat, or QH, which is relatively high temperature. Second, some of the energy from that input heat is used to do work, or W. Third, the rest of the heat is removed at a relatively cold temperature, or Q. Let us find out the 4-cycle stroke of a gasoline engine in the activity below. Activity 1, entitled Start the Engine. Objective: after the activity, the learner should be able to discuss the 4-cycle stroke of a gasoline engine. Materials needed: it's illustration of 4-cycle stroke. Procedure: study the illustration. Figure 1 is the 4-cycle stroke of a gasoline engine. We have the intake, compression, power, and exhaust. Fill in the table. For the cycle stroke intake, movement of the piston moves down. What happened to the mixture of gases? Filled in the cylinder. For the compression, the movement of the piston moves upward. What happened to the mixture of gases? Compressed into fractional amount. For the power, movement of the piston moves down. What happened to the mixture of gases? Ignited by the spark plug. For the exhaust, movement of the piston moves up. And what happened to the mixture of gases? Expelled out by the exhaust pipe. Okay, for the guide questions. Question 1. What happens to the gas if it is heated inside the engine cylinder? When the gases are heated inside the engine cylinder, it results into high temperature and pressure due to vibration caused by movement of gas particles. Increase in temperature and pressure produces internal combustion that direct force to components of the engines, including pistons, turbine blades, and rotor. Question 2. What happens to the piston and the gases during compression stroke? No heat is transferred into the fuel or air mixture. As the volume is decreased because of the piston's motion, the pressure in the gas is increased, as described by the laws of thermodynamics. Thermal efficiency. It was thought before the full understanding of the second law of thermodynamics that at very low pressure much of the input energy ends up doing useful work. The efficiency is calculated as a fraction, although it is stated as a percentage. Efficiency equals work done over input heat equals W over QH. Work is just the input heat minus the exhaust heat, so efficiency is equal to QH minus QC over QH equals 1 minus QC over QH, where QC is the energy removed by heat or energy in cold reservoir. QH is the energy added by heat energy in hot reservoir. TC is the absolute temperature in cold reservoir. TH is the absolute energy in hot reservoir. Note, the temperatures are the absolute temperatures on the Kelvin scale. And that is it for our today's lesson. Please don't forget to subscribe to our YouTube channel, GAITF, or log into our account at lcms.gaitf.com so that you can answer the quizzes and activities given by the teacher. Thank you for listening.